Welcome, friends, to the next concept in integral calculus, that is applications of integration. Applications of integration mainly involves in presently NCERT 12th standard textbooks I am referring. Only it is related to areas of certain curves. Integration, in particular definite integral, I remember having in previous classes explained that a definite integral will give us area under a given curve. That means it is just calculating sum up of all the small areas or domains under a given curve, which you can add up and then say that this is the total area under a given curve. We have to integrate the curve within the limits, lower limit and upper limit. Then you will be getting the area. Then in that case, let us understand practically whether it is really true or not. Let us go to the whiteboard first. How a definite integral will give us area. Okay. So share. Yeah. Now we will be focusing on applications of integration. Applications of integration. We will be discussing mainly about the areas. We don't say any other topic today other than just calculating the area under a given curve. Okay, let us see how to do this. Now, let us take one straight line, one graph like this. I am having a graph called y is equal to x. Now, this graph definitely will pass through origin because y is equal to mx kind of thing. This is x-axis, this is y-axis. Now, if you put the coordinates, let us say 3 coordinates will take 1, 2, 3. This is origin. 1, 2, 3, 1, 2, 3. So if you put x is equal to, let us say 0, you will be getting y coordinate 0. If you put 1, it will become 1. Put 2, it is 2. If you put 3, it is 3. So 0, 0 will be here. 1, 1 is here. 2, 2 is here. 3, 3 is here. So you got all the 3 points straight line. Now I want to find the area under this curve. Okay, between let us say 0 and 1. I'm just writing down here. Find area of y is equal to x between 0, 1. Okay, 0, 1. Actually, I have to put here small brackets. I remember. Oh, no problem. Let us put like this only. Doesn't matter. So 0 and 1 means x-axis 0, x-axis 1. This is the interval. Within this interval, I am supposed to find out the area. So what I do, I will draw a perpendicular here. Geometrically, I am finding out. If you drop a perpendicular, this point you call A, this point you call B. So this area they are asking us to now evaluate. So straight away, let me see. Triangle OAB is a right angle triangle. It is a right angle triangle. So what is the formula for area? Half into base into height. Correct or not? So half into what is OB? OB is nothing but this distance. This is interval. 1 minus 0. That is 1. What is AB? This height. That itself is 1. So totally our area is 1 by 2. So geometrically we got answer as 1 by 2 square units. Now integration I will apply, and as promised, integration also should give me of half value. Then only we will say definite integral will give us areas. What are my limits now? 0 to 1. What is the equation? X dx. Because y is equal to x is the equation, we have to integrate this. So integral x dx 0 to 1. 0 to 1. So what will happen now? Integral x dx will become x square by 2. So what are the boundaries? 0 to 1. First you put upper limit 1 by 2 minus lower limit 0. So half. This and this matched. So you can conclude that definite integral will give us the area under a given curve. Now our curve is nothing but line here. Now let us see one more line, one more drop you will do. 3. Let us say from 2 or 3 or 2 will do. What is there? 2. Please remember this one. 2 now. I'm just trying to find out so that it will become exactly 2 for you. Huh? This 2 I'll erase here and write here. So this is 2 for you. This point now you call C now. Now A, B, E, C, I want to find area. It is a trapezium. I want to find out the area of this by using the integration. What is interval now? 1 and 2. Between 1 and 2, I got one triangle, one diagram. It is now A, C, B, E. So that also will prove now. Okay. Now A, C, B, E is a trapezium. What is the area formula? Area is equal to half into sum of parallel sides into perpendicular distance between them. So what is sum of parallel sides now for me? Half into, just go back to the sketch. This height and this side, these are two parallel sides. AC and BE non-parallel. So AB value is 1 for you. CE value is 2 for you. 2 plus 1 is 3. So sum of parallel sides is 1 plus 2. And perpendicular distance between them, that is nothing but this distance, 2 minus 1. How much it is? 1. So that will become 1. So this value became now for you 3 by 2. We will prove this by integration again. So by integration, limits are now, what are the limits? 1 to 2. Equation is same, x dx. So x square by 2, 1 to 2. So upper limit is 2 square by 2 minus 1 by 2. 2 minus 1 by 2, which is nothing but 3 by 2. So now what is the conclusion then? Definite integrals under given curves will give us areas. Okay, this is very, very important point, which we proved now. Geometrically, we proved the areas equal to the definite integrals. So in real applications, curves will be given, little bit complicated curves will be there, or small curves will be there. All curves can be calculated by using various formulae, and then finally we'll get the areas under the given curves. Let us go to the next sum. Find the area of circle given by equation x square by a square, x square plus y square is equal to a square. That is the equation of circle. Okay, where a is called as radius. Where a is called what? Radius. So let us draw one small circle like this. Center, you choose coordinate system like this. This is our circle. So this is origin. This distance is a because this is radius now. From here to here, this is the distance which is called radius. So now if you observe clearly circle, if you calculate this quadrant area and multiply it by 4, you will be getting the total area. So let us see here what happens. x square plus y square is equal to a square. Okay. We have to now write down expression for y square like this. So y is equal to root of a square minus x square. So you got the equation now for this circle to be integrated. Like in this integration, we have to put the boundaries. Now the circle area, when you are finding out, this area we are finding out, correct? So that means from here to here, this interval we have to choose as limits. Okay. So here what are the limits now? Just starting from origin, that is 0, going up to the end of this, that is radius, up to radius, that is a. So limits for integration, we should always properly select. Limits for integration are 0 and a. So integral 0 to a y dx. This is our integration. What is our y now? Y is nothing but root of a square minus x square dx. So now this formula you can straight away take. Okay. This formula we will take from x by 2, okay, root of a square minus x square plus a square by 2 sine inverse x by a. You no need to do again and again by substitution methods and all. You can take the standard formula. This is a formula. So that you can substitute here, and these are the limits. So first upper limit, then the lower limit. What is upper limit? X by 2 root of a square minus. So first lower limit, upper limit only. A square minus a square. A square minus a square. Because wherever x is there, you should write a now. Plus a square by 2 sine inverse a by a. This is called your upper limit. Now let us put the lower limit. What is the lower limit? 0 is lower limit. So 0 by 2 root of a square minus 0 square plus a square by 2 into sine inverse 0 by a. Okay. This is the lower limit. So when you are simplifying this, this will become 0. So here you are left with only a square by 2 sine inverse 1. This side 0 into anything is called 0. Sine inverse 0 is 0. Please remember this. Okay. Sine inverse 0 is also 0. So we are only having this now. What is sine inverse 1? Sine 90 degrees is called 1. Or 90 degrees in radians we will write generally pi by 2. So therefore pi by 2 is equal to sine inverse 1. So this we should know. So a square by 2 sine inverse 1 will become a square by 2 into pi by 2, or simply pi into a square by 4. Understood? So this is only one quadrant area. What we found out is called integral y dx between 0 to a. This for one quadrant. So one quadrant is equal to pi a square by 4. So therefore, area of a circle is equal to 4 quadrants are there. 4 into pi a square by 4. Cancel off. You will get only pi a square units. So this is the area of circle. So if you are given, let us say in terms of numbers, x square by 4 or something, x square plus y square. Say for example, x square plus y square is equal to 9. For this area, for 1 mark sometimes, without having to work, straight away pi a square. Pi into a value here 3. So 9 pi answer. So if you remember this, you will be able to do for 1 mark. Generally, this will be coming for in the examination. You have to work out. You have to derive this area formula. So let us go to the next sum. This is find the area of ellipse. Find the area of ellipse. X square by a square plus y square by b square is equal to 1. Same like previous sum. So here we have to draw one small ellipse. Define the coordinate system. This is your A, this is your B, O, A, B. So if you find out only this area, multiply by 4 and you'll get the total area of the ellipse. So let us see how to do that. So x square by a square plus y square by b square is equal to 1. So y square by b square is equal to 1 minus x square by a square, or nothing but a square minus x square by a square. This is y square by b square. So this you send this side. So y square is equal to b square by a square into a square minus x square. So therefore y is equal to root of b square by a square into a square minus x square, which is nothing but b by a root of a square minus x square. So we brought out a single expression for y. Now with this, we will try to find the area. Integral y, we will use. Now what are the limits? Since it is bounded to x-axis, this is x-axis for you, this side is y-axis. This is nothing but radius. So a, 0 to a. So integral y dx between 0 to a is equal to b by a integral 0 to a root of what we are having here, root of a square minus x square. Root of a square minus x square. Observe clearly, huh? A square minus x square. So now, when we are integrating this, already we have done previously. B by a, open the bracket, x by 2 root of a square minus x square plus a square by 2 sine inverse x by a, limits 0 to a. Carefully we have to do applying the limits. B by a, first flower bracket you open, x by 2, a by 2 root of, wherever x is there we should write a square, wherever x is there we should write a. Okay, sine inverse a by a. This is upper limit is completed. Lower limit 0 now. 0 by 2 root of a square minus 0 square plus a square by 2 sine inverse 0 by a. Close the bracket. So what happens now? B by a, this is 0. We are having only a square by 2 sine inverse 1 minus this is 0. This is also 0. So we are having only b by a square by 2 sine inverse 1 already you know is pi by 2. So now this is only area of one quadrant of the ellipse. So like this 4 quadrants we are having. So area of ellipse is equal to 4 into b by a into a square by 2 into pi by 2. So 2, 2, 4 cancel. A will go one time. So pi a b is the answer. So remember this point very, very clearly. So for ellipse pi ab, so any sum when it comes in the 1 mark, x square by a square plus y square by b square or something, then you can find out the a value and b value, multiply with pi, you will be getting the area of the ellipse. Yeah, Let us go to the next sum. How to find out the area of parabola. Okay. So now we are trying to find out the area of parabola y square is equal to 4ax by integration method. That is by our definite integral principle. So here, that means we are supposed to find out integral y square dx we call directly between what limits? Here, y stands for root of 4ax. So we are supposed to do with respect to x. Then limits. What are the limits now? Let us draw the parabola. This is how it looks like. Now, since they have given no limit for us, we are supposed to understand, like in our circle equation, we have seen that x square plus y square is equal to a square, where we have taken limit from 0 to a. A stands for their what? The radius point. So now here also for this parabola, there will be a fixed point. If you know the conic sections definitions for the parabola, there is a fixed point called focus. So this distance is small a from here to here. So we have to integrate this between 0 to a. Now if you see clearly, this line is dividing this part area into like this two parts. So if you find the upper part and multiply it by 2, you will get the total area. So we will write here 2 integral 0 to a. If you do this, you'll get the area of the parabola. Let us start doing this. 2 into root of 4 means 2. Root of a means root a. Integral 0 to a root x dx. So what is root x here? It is nothing but x to the power of half. So after integration, that will become half plus 1 by half plus 1 between the limits 0 to a. So here half plus 1 means 3 by 2. 2 will go to the top. 4 into root a into 2 divided by 3, open the bracket, x to the power of 3 by 2 between 0 and a. So 8 root a by 3, open the bracket, a to the power of 3 by 2 minus 0. So this stands now here a to the power of 3 by 2, here a to the power of half plus 3 by 2. So 8 by 3 into 1 by 2 plus 3 by 2, 4 by 2. So a square. So you got here 8 by 3 a square as the area of the parabola after multiplying with 2. Let us check again. See root of 4ax. Root 4a means 2. Root a comes out. Then root x means x to the power of half plus 1 by half plus 1. So this is 2 by 3. Outside you write like this. X to the power of 3 by 2 means a to the power of 3 by 2 minus 0 lower limit after applying the limits. Then 8 by 3 into root of a means a to the power of half plus a to the power of 3 by 2. Both the powers you can add by our theory of indices. So 3 by 2 plus 1 by 2, 4 by 2, that becomes a square. So this is the area of the parabola. Let us see another sum. Find the area of the region. Find the area of the region bounded by y square is equal to x and x is equal to 1 and x is equal to 4. So this is also previous without any limit that time. Now we have got a limit. In this region they have defined. So this is called as 1. This is called as 4 on the x-axis. So now we have to integrate this equation within this region. So now this one again 2 you have to multiply so that you will get the total area. So root x, so why root x is coming? Y square is equal to x. So this implies y is equal to root x. So integral 0 to, sorry, not 0 now. It limits are 1 to 4. Because region of interest is only this. This region 1 to 4 only it is line. So let us write down 1 to 4 dx. So again x to the power of half plus 1 by half plus 1. Here 2 I am writing. Okay. Limits are 1 to 2. Outside 2 is there. So 2 open the bracket. X to the power of 3 by 2 divided by 3 by 2. Limits are 1 to 2. 1 to 4. Sorry. Here 1 to 4. So 2 open the bracket. Here again 2 by 3. First upper limit 4 to the power of 3 by 2 minus 1 to the power of 3 by 2. So 2 into 2, 4 by 3. 4 to the power of 3 by 2 means it is 2 square. Okay, all to the power of 3 by 2 you can write down minus 1 to the power of anything is called 1. So here 2 and 2 will get cancelled. So you'll get only 2 cube. 4 by 3 outside. 8 minus 1. 8 minus 1. That means 7. 7 into 4 by 3. 28 by 3. This is the area. Very simple sums. These are all. Just keep practicing. And then another interesting sum we'll do. That is circle and one line. This will be the last sum for this particular topic. Find the area shaded in the diagram. In the given diagram. Very interesting and important sum also. What is the sum they have given? One circle is there. This circle equation they have given. X square plus y square is equal to 4. And they have given one line passing through the horizon. This line equation they have given x is equal to root 3 into y. This is the equation of the line. And this is the equation of the circle. So let us see what they're asking you to find out. I am dropping one perpendicular from the point of intersection here. They're asking find the area of this shaded region. So now shaded region includes, there are two pictures, OBM, BMA. Okay, now you are seeing this. So we have to integrate this line equation from 0 to m and curved part. So if I draw this for you, like this, O, M, A, B. So now curved part is a sector. Okay. Then we have to find the area of this shaded region and this also. So we will integrate this circle part within these limits between m and a, and then we have to also integrate the line equation between 0 and m limits. So first, what are the x values at m? At O it is 0, but at m we should find out. So x square plus y square is equal to 4. Since x is equal to root 3y is intersecting the circle at B and D. 2 points it is intersecting. Then x square plus wherever x is there, the circle equation, you substitute this. Then x square plus 3y square is equal to 4. Oh, sorry, here root 3y, x square plus in the place of y we should write x by root 3. Here we must write x by root 3 because in the place of y we should write this. In the place of y we should write, so y is equal to x by root 3. Therefore, from this equation, x square plus x by root 3 whole square is equal to 4, or x square plus x square by 3 is equal to 4. This implies 4x square by 3 is equal to 4. Cancel 4 and 4. X square is equal to 3, or x is equal to root of 3. Actually, plus or minus you can take. But since we are considering the area in the first quadrant, you can choose only plus root 3. So since area is in first quadrant, x is equal to root 3 can be taken. Only plus root 3 we can take. So now that means what our limits are. Therefore, limits for line x is equal to 0, comma, then root 3. Then limits for sector x is equal to root 3 and x is equal to 2. Observe clearly. This is the equation given, circle. So the line is going like this. It has cut here. So this point is called as root 3. Circle radius is totally 2. So up to this point, OA value is always 2. That is this 2. Then this point is root 3 from here to here. So that is where root 3 came. So integral. So total area is sum. What are the both areas? One is called as x by root 3, 0 to root 3, plus integral root 3 to 2 root of 2 square minus x square dx. Because here, if you observe clearly, x square plus y square is equal to 2 square. So y square will become 2 square minus x square. So y will become root of 2 square minus x square. That is how you got this. So now we have to integrate these both equations. First one you see 1 by root 3. This root 3 take out. So this will become x square by 2 between 0 to root 3. So this will become now 1 by root 3 into root 3 whole square by 2 minus 0. This will become 1 by root 3, open the bracket, 3 by 4 minus 0. Because root 3 whole square is called 3. By 2 square is root 3 whole square only, no, 3 by 2 is sufficient. Only x square. X square means only root 3 whole square by 2. So this will become whole together root 3 by 2. This is the first integral. This is called second integral. Now we will evaluate the second integral. Integral root 3 to 2 root of 2 square minus x square. So what is the formula? This is root of a square minus x square. What formula is there? X by 2 root of a square minus x square plus a square by 2 root of sine inverse x by a. Okay. So now this sum will do like that only. X by 2 root of 2 square minus x square plus a square by 2. 2 square by 2 sine inverse x by a. A is called 2. So what are the limits? Root 3 to 2. These are the limits. So first put the upper limit. 2 by 2 root of 2 square minus 2 square plus 2 square by 2 sine inverse 2 by 2. This is the upper limit. Lower limits. Root 3 by 2 root of 2 square minus root 3 whole square. 2 square minus root 3 whole square plus a square by 2. A square means 2 square only. A square means 2 square. 2 square by 2 sine inverse x by 2 root 3 by 2. Close the bracket. Here this term will go cancel because 2 square minus 2 square 0, 0. So this will become 4 by 2 sine inverse 1 minus this side. Root 2 whole square means 4. This is 4. Sorry, 2 square means 4. 4 minus root 3 whole square. Root 3 whole square is called 3. So 4 minus 3 will become 1 there. So here root 3 by 2 into 1, this bracket, plus 2 square by 2 means 4 by 2. Sine inverse root 3 by 2. Sine inverse root 3 by 2 means sine 30 degrees is called half. Sine 60 degrees is called root 3 by 2. So you can write here pi by 3. Next, 4 by 2, 2 sine inverse 1 means pi by 2 minus here how much will come? Root 3 by 2 plus 2. This will go 2 times 2 pi by 3. Okay. So this 2 and this 2 also will go cancelled. So we are having pi minus root 3 by 2 plus 2 pi by 3. Okay. Now this is second answer, second area. First area, second area, we have to add 1 plus 2. Therefore, total area is equal to first one what we evaluated plus second one. First one we got as root 3 by 2. What about the second one? Pi minus root 3 by 2 plus, when you are multiplying inside, minus root 3 by 2 minus pi by 3. See here, when you are multiplying inside, this sign also will become minus. Minus root 3 by 2 minus 2 pi by 3. So both will become minus sign. Carefully we should do minus 2 pi by 3. So root 3 by 2, root 3 by 2 cancel. So we are having only pi minus 2 pi by 3. That means finally the answer is 3 pi minus 2 pi. 2 pi by 3. Okay. So first one we got root 3 by 2. This is correct. Then second one we got as pi minus root 3 by 2 minus 2 pi by 3. How 2 pi by 3 we got here? Sine inverse root 3 by 2. Okay. So overall this and the first one we added. Correct. So let me check whether this answer is correct or not. Yes, our answer is correct. So friends, I will conclude here. We are supposed to now practice regularly these definite integrals and hope you will become perfect by doing this NCERT exercise sums and some marked examples also. So I will wind up this definite integrals chapter at this level. Thank you so much. Keep revising.